Okay, we've looked at the end behavior of some higher degree polynomials, so we know what's happening when that x value goes to infinity or negative infinity. But we want to find the x-intercepts. We want to find that stuff that's going on in the middle of the graph. The first thing we're going to try is a thing called factoring by grouping. We saw this in class, where we take the first two terms, put that in a group, and we're going to take the next two terms and put that in a group. Just like this. Now, if we bring these signs with us, we see subtract 25x. If we take that as a negative 25x, we can write add right there, right? Add a negative is the same as subtract, add a negative. Now, we can look at each group and see if there's anything that comes out as a common factor in this first group. I see x squared. And if that comes out, I'm left behind an x, and I'm left behind a 3. If I were to redistribute this, I'd get that back. Looking in my second group, I see that negative 25 is a shared factor, and what's left behind is an x, and in fact, a positive 3, right? If we took negative 25 multiplied by positive 3, we get negative 75. Now, this process will sometimes unveil that both of these groups have this shared factor. Right? You see x plus 3 times x squared and x plus 3 times negative 25. So what that lets us do is write the group, that factor, right out here, x plus 3. We think about what was left behind. We had x squared and negative 25. So we can write that as a second group, just like that, bringing our y down to keep things organized. Now notice, if we distributed here, if we took this x times x squared, we get our x cubed back. X times negative 25 would get us our negative 25x. 3 times x squared would get us our 3x squared, and 3 times negative 25 would get us our negative 75. So we'd actually get back the original equation if we were to multiply using distribution right now. But we're not. We're trying to go the opposite way. We're trying to get down to all first degree x terms so that we can find our x-intercepts. So we're actually good with this x plus 3, and now I'm looking at this x squared minus 25 and thinking about how can I take this quadratic and factor it even further. I want x to the first degree. I want x to the first power. I'm going to use, there's a lot of things that we can use at this point. We could use quadratic formula or any of our other factoring methods, but I'm going to use the a, b, and c. So my a is 1, my b is 0 because that x term is gone, and my c is negative 25. Looking for anything that multiplies to negative 25 and adds to 0, I find negative 5 and positive 5. Those multiply there and add there. So that makes me happy. I've got y equals the x plus 3 that I got from grouping and factoring. And then I have x minus 5 and x plus 5. Again, knowing that all of my x-intercepts happen when y is 0, I can set this to 0 and think about, well, I've got these 3 factors. When they multiply together, they're going to equal 0. So using the 0 product property, I know that each of them has the possibility of equaling 0 and giving me one of my intercepts. And so now all we have to do is think about what does x have to be here? Well, that would be negative 3. This would be positive 5. And this would be negative 5. And there are my zeros, or my x-intercepts, or my roots, whatever you want to call them. That is the goal. Good luck.